So starting with the pop quiz discussion, the measurement, work energy and power. In question one, a pendulum swings with a time period of approximately 1 second. Describe how to use a stopwatch to determine the time period as accurately as possible. Like how we can work out the time period. So first, we'll mark the fiducial point, like the mean and the extreme position. Say there's a pendulum, we mark its mean position, and then we'll mark its extreme position. And we release this pendulum from its extreme position, and at the same time, we'll start the timer. So when we release this pendulum from extreme position, it will move to mean position, then to other extreme, and then return back. That is called a time period. But for accurate determination of the time period, we don't record the time for one oscillation. We record for time for like 10 oscillations or 20 oscillation or 15 oscillation. So the points which will score the marks here, first you will mark uh, the mean and extreme position. And then we will reset the stopwatch. Then record the time for 20 vibrations or oscillations. It's the same thing. So we'll record the time for 20 oscillation, like we'll know how much time it will take for 20 vibrations. And then the time period will be the total time divided by number of oscillations. So it will be total time divided by number of oscillations. So in this case, the number of oscillation are 20. So that will be divided by 20. So whenever we want to determine the time period as accurately as possible, we reset the stopwatch, we mark mean and extreme position, we release the pendulum from its extreme position. The moment we release, it will move to its mean position, then to extreme, and then return back. So that is, this one is known as one oscillation, and the time to complete one oscillation is called time period. But practically, it will be difficult to record the time for one oscillation as the reaction time is also involved. So to reduce the percentage uncertainty, we record the time for 20 oscillation and then the total time divided by number of oscillations. Is it clear, this one?
Yes, sir, clear.
The next one, table 2.1, by writing in each space the right-hand column, which one of the following device is used to measure the quantity on the left column. So if you want to measure the volume of a water in a glass, so which apparatus is suitable? For that case, we need a measuring cylinder. Measuring cylinder is suitable. If you want to measure the width of a small swimming pool, so if we want to measure the length of which one of micrometer is for a short length, like a smaller length or size, so we need a meter rule for that. And if you want to measure the thickness of a piece of aluminum foil, so aluminum foil is not very thick, so what we can use a micrometer for that. So for short length, micrometer; for longer distances, meter rule, or if it was a say a measuring tape was there, so we can mention that as well. The next question, a tidal power drives most of its energy from the moon and a part of its energy from sun. So mainly the tidal energy is due to moon, and a part, a small proportion is there because of sun. Still, one other source of power which derives it energy from the sun. So other than tidal, what else can be driven by this energy of the sun? So we can mention many possible answers are there. You can mention like wind energy, wave energy, or hydroelectric, or fossil fuels also, because these fossil fuel trap the energy of the sun. So many possible answers are there. Wind energy, that is a simple one. State one source of power which does not derive its energy from the sun. So what does not derive from the sun? So two of them are there. One is a nuclear, because tidal is already mentioned. So we can mention nuclear energy, or we can also mention geothermal, the energy from the hot rocks of earth core. That is a geothermal energy. In part B1, figure 3.1 shows a small water turbine driven by a tidal flow of water to generate electricity. Explain whether this method of generation of electricity is renewable. So how we identify it's renewable or non-renewable? We have to check like how it is so. We have to check how it is like rate at which we consume and the rate at which it is produced. That is having a greater difference. Like consumption is less and the production is more. And we have to check which source is like unlimited resources there, then also it will be renewable. So explain whether this method of generating because this is from the tidal and tidal is renewable. But then the second part is you have to mention why it is a renewable. So you can mention here like rate at which it produces much higher at rate at which it consumes. And here nothing is consumed here, only it is produced. Like tides are there and then it produce, the flow is producing electricity, but it's not shown that it is used, like it's not mentioned how much of energy is used. So you can refer that as well. Or you can also mention like tides are continuous or regular and it happen every day, or it is always there, you can also mention. So always there, that is also a word you can use. Or rate at which we consume is smaller as compared to rate of the production, so it will be a renewable energy. In the second part, the mass of a water passing through the turbine in each second is 6 exponent 3 kg. So that is a mass. The speed of the water is 2 meter per second. 400% of the kinetic energy of a water is converted into electrical energy. Calculate the power generated. How we can calculate the power? We know power is equals to work divided by time, or power is energy divided by time. That's a formula to calculate power. And whenever a question is there of 4 marks, so what this give an idea? This give an idea that at least you have to use two different formulas, because if it was a 2 mark question, then one formula is enough and 1 mark for answer. So whenever a question is here of 3 marks, 4 mark, it means you have to use two, or usually 4 marks means you have to use two formulas. So first, what we will do, the water passes through a turbine each second. That is the mass of the water. The speed of a water is 2 meter per second. And 40% of the kinetic energy is converted into electrical energy. We need electrical power generated. So formula for efficiency, efficiency is the useful energy times 100 divided by input energy. That's a formula for efficiency. So an efficiency is denoted by N. So efficiency is equals to useful energy. What is the useful energy? Because we are generating electricity, so electrical energy is a useful energy. So, and what is the input energy? The input energy is a kinetic energy, because what happened? The water flow, like when the water is moving, it will have a kinetic energy. When it flow, it rotate the turbine. and turbine connected to generator produce electricity. So it is giving us electricity. So output is electrical, useful output, and the input is kinetic. Then we'll just substitute the values as the efficiency is 40%. So in place of efficiency, we write 40. In place of efficiency, we write 40. The electrical energy, we don't know, multiplied by 100 divided by kinetic energy. How we can work out the kinetic energy? So for kinetic energy, we have the formula that kinetic energy is half mv square or 0.5 mv square. So it will be half, the mass is 6,000, 6 into 10 power 3, and the speed is 2. So it will be square. This will give us the kinetic energy. What is the kinetic energy of the water? Using a formula half mv square, that is 12,000. Okay. So that is equals to 12,000 joules. So we have this 12,000. Now we need electrical energy, because from electrical energy we'll find the electrical power. So this 12,000 is divided, other side will be multiplied. So 40 multiplied by 12,000 divided by 100. So when the zeros will cancel with here. So it will be 4,800 and the unit will be joules. That is the electrical energy. Now we need the electrical power generated. So from electrical energy, how we can work out the power? So if we need the power, we have the formula power is energy divided by time. So electrical energy is 4,800. And in the question, the time they mention each second, like every second, this much mass is moving. So time is equals to 1. So 4,800 divided by 1. So we get again 4,800 and the unit of the power is watt. So as you can see here, we first use a formula for kinetic energy to get how much kinetic energy input is there. And using a formula for efficiency, we find how much electrical output is there. And then to calculate a power, energy divided by time. So 4,800 divided by 1, we get 4,800. Is this clear, this question? Anyone having a doubt?
No doubts.
So this was the assessment related to measurement work. It is not word, it's work, energy and power.